Hello everyone, Dennis here. Welcome to my lesson. This is GCE O Level Mathematics, Lecture 16, Introduction to Algebra. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. Here are the learning objectives that we want to achieve in this lesson. Number 1. Use letters to represent numbers or variables. 2. Interpret algebra notations. 3. Evaluate algebraic expressions and formula. And 4. Express real-world situations in algebraic terms. Let's start the lesson by learning how to use letters in algebra. Here is a simple case. A pen is sold at $2. A stapler is sold at $3. In arithmetic, if we buy 3 pens and 4 staplers, then the cost is 3 times 2 plus 4 times 3, which is $18. If we buy 5 pens and 2 staplers, then the cost is 5 times 2 plus 2 times 3, which is $16. On the other hand, in algebra, if we buy X pens and Y staplers, then the cost is C equals X times 2 plus Y plus 3, which is C equals 2X plus 3Y dollars. If we buy A pens and 5 staplers, then the cost is C equals A times 2 plus 5 times 3, which is C equals 2A plus $15. In arithmetic, numbers with definite values are manipulated. In algebra, alphabetical letters or symbols are used to represent unknown numbers or just unknowns. Commonly used letters are X, Y, Z, A, B, C, P, Q, R. Can be capital letters such as capital X, Y, Z, capital A, B, C, and capital P, Q, R. Here are also some commonly used symbols such as theta, alpha, beta, epsilon, rho, and sigma. In the above example, A represents the number of pens bought, and it can vary with any whole number. Hence, it is called variable. Since the value of A is not affected or dependent on other variables, it is also called independent variable. C, which is also a variable, represents the cost in dollar, and its value is dependent on the value of A. Hence, it is called dependent variable. An algebraic expression involves numbers and letters that are connected with operation symbols such as plus, minus, times, and divide. In the above example, 2a plus 15 is an expression. Other examples are 2a plus b, x over 2 minus y over 3, alpha square plus beta square, c divided by r. 2a plus b is an algebraic expression in two variables a and b. 2 times a or 2 bracket a or a times 2 is written as 2a. The multiplication sign times is omitted and the number is placed in front of the variable. In arithmetic, 2 times 8 should not be written as 28 or 28. It can be written as 2 times 8 or 2 bracket 8. 1 times a or a times 1 is written as a. It should not be written as 1a. Basic notations in algebra. There are some rules that we need to follow when we want to write an algebraic expression. Let's learn how to write in this section. Example 1. Jeremy is 15 years old now. What is his age after A. 3 years, B. 8 years, and C. X years. Here is the solution. The present age for Jeremy is 15 years. Hence, for A, age after 3 years will be 15 plus 3, which is 18 years. For B, age after 8 years will be 15 plus 8, which is 23 years. For C, age after X years will be 15 plus X years. Example 2. Laura's pocket money is $3 less than twice Audrey's pocket money. What is Laura's pocket money if Audrey's pocket money is A. $5, B. $12, C. P dollars? Here is the solution. Let L to be Laura's pocket money and let A to be Audrey's pocket money. Therefore, L equals 2A minus 3. As mentioned in the question, Laura's pocket money is $3 less than twice Audrey's pocket money. For A, given A equals 5, therefore L equals 2 times 5 minus 3, which is $7. For B, given A equals 12, therefore L equals 2 times 12 minus 3, which is $21. C, given A equals P, therefore L equals 2 times P minus 3, which is 2P minus 3. Here is the summary of basic notations in algebra. In the operation of addition, the arithmetic statement can be add 3 to 4, or 3 plus 4, or the sum of 3 and 4. In arithmetic expression, it can be written as 3 plus 4 or 4 plus 3. In algebraic statement, it can be said as add x to y, or x plus y, or the sum of x and y. In algebraic expression, it can be written as x plus y, or y plus x. For the operation of subtraction, the arithmetic statement can be subtract 3 from 4, or 4 minus 3, or the difference of 3 and 4. Hence, in arithmetic expression, it can be written as 4 minus 3, but it is not equals to 3 minus 4. In algebraic statement, subtraction operation can be mentioned as subtract y from x, or x minus y, or the difference of x and y, where x is greater than y. Hence, in algebraic expression, can be written as x minus y, but it is not same as y minus x. For multiplication operation, the arithmetic statement can be multiply 4 by 3, or 4 times 3, or the product of 3 and 4. In arithmetic expression, it can be written as 4 times 3, or 3 times 4. For algebraic statement for multiplication operation, we can say that multiply x by y, or x times y, or the product of x and y. In algebraic expression, it can be written as x times y, or y times x, or just xy. In operation of division, arithmetic statement can be written as divide 4 by 3, or 4 is divided by 3, or quotient of 4 divided by 3. In arithmetic expression, it can be written as 4 divided by 3, or equals 4 over 3. However, it is not equals 3 divided by 4. Similarly, in algebraic statement, it can be stated as divide x by y, or x is divided by y, or quotient of x divided by y. In algebraic expression, it can be written as x divided by y, or x over y, but it cannot be written as y divided by x. Index notation. In arithmetic, 2 times 2 can be written as 2 squared, 3 times 3 times 3 can be written as 3 cubed, 4 times 4 times 4 times 4 can be written as 4 to the power 4. 5 times 5 times 5 times 5 times 5 can be written as 5 to the power 5. In algebra, w times w can be written as w squared, x times x times x can be written as x cubed, y times y times y times y can be written as y to the power 4. Z times z times z times z times z can be written as z to the power 5. However, w plus w can be written as 2w but not w squared. X plus x plus x can be written as 3x but not x cubed. Y plus y plus y plus y can be written as 4y but not y to the power 4. Z plus z plus z plus z plus z can be written as 5z but not z to the power 5. Let's look at example 3. Simplify the following. A. X times y times 3 times x. B. 3a times 4b times b times a. C. T times s divided by 5 times s. Here is the solution. For A, x times y times 3 times x can be rewrite as 3 times x times y, which is 3x squared y. For B, 3a times 4b times b times a can be rewrite as 3 times 4 times a times b, which we get 12ab squared. For C, t times s divided by 5 times s can be written as t times s over 5 times s, which we get s squared t over 5. Example 4. Express the following statements with algebra. A. Multiply the sum of twice the x and half of y by 3. B. Subtract the square of A from the square of B. C. Add the difference of alpha and beta to theta given alpha is greater than beta. D. Divide the product of P and Q by the cube of R. So here's the solution. For this type of question, you have to be careful with the statement. Read the statement carefully and form the necessary expression. So for A, the sum of twice the x and half of y can be written as 2x plus y over 2. Then followed by multiply by 3. Hence, this whole thing times 3, or we get 3 bracket 2x plus y over 2. For B, subtract the square of A from the square of B. So the keyword subtract. So we know it will be something minus something. Next, square of A from square of B. So it will be B squared minus A squared. For C, the keyword is the difference of alpha and beta given alpha is greater than beta. So remember, difference is always the greater value minus the smaller value. Hence, for this case, it is alpha minus beta. Then add to theta. So we add the whole thing to theta. Or just remove the bracket, alpha minus beta plus theta. For D, start with product of P and Q, which can be written as P times Q, then divide by the cube of R. So we will write divide by R cube, and simplify, we get PQ over R cube. Next, let's discuss about evaluation of algebraic expressions. Evaluate means find the value of. It is a process of replacing each variable with its value to find the actual value of an algebraic expression. It is also known as substitution. Let's look at example 5. Evaluate the following expressions when a equals 3 and b equals -1. A. 4a minus 3b. B. a squared b plus 5b squared minus 8. C. Half times 3a plus 5ab. D. 7ab minus b plus 7 over 3b minus 4a. Here's the solution. When a equals 3 and b equals -1, then for a, 4a minus 3b equals 4 times 3 minus 3 times -1, which is 12 plus 3, and the value is 15. For b, a squared b plus 5ab squared minus 8 equals 3 squared times -1 plus 5 times 3 times -1 squared minus 8, which is -9 plus 15 minus 8, and the value is -2. For C, half times 3a plus 5ab is half times 3 times 3 plus 5 times 3 times -1, which we get half times 9 minus 15, and the value is -8. For D, 7ab minus b plus 7 over 3b minus 4a, and it is equals to 7 times 3 times -1 minus -1 plus 7 over 3 times 3 minus 4 times -1. So we calculate the values, we get -21 plus 1 plus 7 over 9 plus 4, which is -13 over 13, or -1. Next, formula. What is a formula? Formula is an equation that connects two or more variables. Here are a few examples. The area of triangle is half times base times height, and we can write as a equals half bh. This is the formula for the area of triangle. Another example, speed equals distance over time, hence the formula for the speed will be s equals d over t. We can find the value of a and s from the examples above by substitution. When b equals 12 cm and h equals 7 cm, then the area A will be half times 12 times 7, which is 42 cm square. When d is 120 kilometers and t equals 1.5 hours, then the speed s equals 120 divided by 1.5, which is 80 kilometers per hour. So this is substitution method. Example 6. The area of a circle is given by the formula a equals pi r squared, where pi is a constant. Find the value of the area when a, pi equals 3.142 and r equals 14 cm. B, pi equals 22 over 7 and r equals 28 cm. So here's the solution. For a, when pi is 3.142 and r is 14 cm, then the area equals pi r squared will be 3.142 times 14 square, and the value is 616 cm square, rounded up to 3 significant figures. For b, when pi equals 22 over 7 and the r equals 28 cm, hence the area will be pi r squared, which is 22 over 7 times 28 square, and the value of the area is 2,464 centimeters square. Let's learn how to translate real-world situations into algebraic expressions. Algebraic expressions and formula are used to express the relationship between two or more quantities in our daily life. Here are a few tips that can help you. First, read the questions carefully. Make sure you understand the questions before forming expressions and formula. In many cases, we let x to be the unknown that we want to find. then some other quantities in the same case can be expressed in terms of x. Let's look at example 7. Bernard has $5 more pocket money than Mei-Ling. A. If x is the amount of Bernard's pocket money and y is the amount of Mei-Ling's pocket money, form a formula connecting x and y. B. If Mei-Ling has $28 pocket money, how much pocket money does Bernard have? Here is the solution. For A, x will be equals y plus 5 as Bernard has $5 more pocket money than Mei-Ling. Or we can also write the formula as y equals x minus 5. For B, given that y equals to 28, since Mei-Ling has $28 of pocket money, therefore x equals y plus 5 will be 28 plus 5, and the value of x is 33, which means Bernard has $33 of pocket money. Example 8. In a fun fair, the number of children is 25 more than the number of adults. The number of men is 18 less than half of the number of women. A. If x represents the number of children and y represents the number of women, form an equation connecting x and y. B. If there are 90 women, determine the total number of visitors in the fun fair. Here is the solution. For A, the number of men equals 18 less than half of the number of women. And we can write this statement into expression, which is y over 2 minus 18. Then the number of children will be 25 more than the number of adults. So we can write as x equals y plus y over 2 minus 18 plus 25, where y is the number of women, y over 2 minus 18 is the number of men. Then we simplify this equation, we get x equals 3y over 2 plus 7. B, so when y equals 90, then number of men will be 90 over 2 minus 18, which is 27. Then x will be 3 times 90 over 2 plus 7, which is 142. So this is the number of children. Then the total number of visitors will be the sum of the number of men, the number of women, and the number of children. And the values are 27, 90, and 142 respectively. So the total number of visitors are 259. In summary, algebra uses letters and symbols to represent numbers. Here are the 4 operations of algebra. The first one is the sum of x and y can be written as x plus y. Number 2, the difference of x and y can be written as x minus y, where x is greater than y. Remember, the difference is always the bigger value minus the smaller value, and its value must be positive. 3. The product of x and y can be written as xy. 4. The quotient of x divided by y is x divided by y or x over y, where y is not equals to 0. In index notation, x cubed equals x times x times x, and it is not equals 3x because 3x equals x plus x plus x. 1 times x equals x times 1, which is just x. Algebraic expressions involve numbers and letters that are connected with operations such as plus, minus, times, and divide. So here are a few examples like 3a plus 2b, 2x squared plus 3x plus 1, P over R plus 5. Substitution. Variables in an expression can be substituted with their values to evaluate or to find the value of the expression. Here is an example. When n equals 5, then the expression n minus 2 times 180 equals 5 minus 2 times 180, which is 3 times 180, and the value is 540. A formula is an equation that connects two or more variables. Here are a few examples. The area of a trapezium, A equals half times A plus B times height. Also, the formula of simple interest, which we have learned in the previous chapter, I equals PRT. And the formula for the compound interest is S equals P bracket 1 plus I to the power n. The value of a variable in a formula can be found by substitution if the values of other variables are known. So here is an example. When P is 3000, R is 0.02, and T equals 5, then the I equals PLT is 3000 times 0.02 times 5, which is 300. In many real-world situations, we let x to be the unknown that we want to find. Then, some other quantities in the same case can be expressed in terms of x. Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment area. I would love to hear from you. Do you like this video? Please don't forget to like it and share it to your friends. Until then, see you in the next video. Have a great day ahead.